Grade 9s, and welcome to this video where we're going to be dealing with exponents. I know this is a part that's very, very important. And please, if ever you need to know your exponent rules, and you should be able to, especially also in grade 9, work with a negative exponent, turning it into a positive exponent. So let's get started. With exponents, there's 4 laws that are very, very important to remember. Law 1 is where you multiply with 2 variables. The bases at the moment, can you see that is my base? And the exponent is the 3 and the 1. Okay, so just when we talk about the base, that will be the x and the exponent is a 1. So the law 1 says if you are multiplying, you need to have the same base, so you keep the same base and you're going to add the exponent. So 3 plus 1 is 4. All right, so it does get a little bit more intricate after this. So I'm just going to explain the basic laws again, and then you'll see we move into quite some challenging sums as well. So over here, now the kids in my class always, when you change the x9 sort of into a 2, they want to write 2 times 2 is 4. But please, that is incorrect. So the rule is you keep your same base. So the base is now the 2 and the exponent is 3. So you keep your same base and you add the exponents. 3 plus 2 is 5. And then you're welcome to go and put that into your calculator. 2 to the power 5, which will give you 5, which will give you 32. All right, so you're welcome to simplify, especially those easier ones. Okay, law 2 is when you divide. So this line over here tells me it's a division. So x to the power 10 divided by x to the power 4. You keep your same base, and now instead of adding the exponents, you subtract your exponents. 10 minus 4 is 6. All right, then now again your base, I'm changing my bases to numbers. So you keep your same base and you subtract the exponents. 5 minus 3 is 2. Then you're welcome to simplify that into 4. But again, just be careful. The bases are now a number, but the rule is you keep the same base and you subtract the exponents because it's division. All right. Law number 3 and law number 4 goes hand in hand closely together. With the one, just to explain it very carefully and slowly, if you've got a base with the exponent, and that is all raised to a further 2, then that means you keep the base and you multiply. So exponent, a power raised to a further power, you multiply together. So that will give you x to the power 6. And the same here, even if it's a negative, you keep your base. Negative 3 times negative 2, so a negative times a negative is a positive, and 3 times 2 is also 6. All right, but we'll deal with if you've got a negative exponent just now in slide soon hereafter. Okay, so over here, everything inside that bracket is raised to the power 2. So everything, I always bellow from a very deep voice, everything inside the bracket is to the power 2. So we start with a negative. A negative raised to an even number, and just write my answer here on top, becomes a positive. So you can write that positive. We don't normally write it, so I'm just going to erase it again. But just to reiterate, a negative raised to an even number becomes a positive. Then the number. So remember, the number has an exponent of 1, and 1 times 2 is 2. So 2 to the power 2 is 4. So what you can remember is the number we raise to the power as normal. So you're not going to say 2 times 2. It's 2 to the power 2, which gives you 4. And then we've got x's and y's, and a power raised to a further power, you multiply together, and 3 times 2 is 6. Okay, over here, a negative raised to an odd number stays a negative. Okay, so again, a negative raised to an odd number stays a negative. 3 to the power 3 is 27. Then we've got x's and y's. X, there's a 1 over there. Power raised to a further power, you multiply together. So it will be x to the power 3 and y to the power 2. 2 times 3 is 6. And there's your answer. All right, now let's look at a few rules to remember. The zero exponent rule is anything to the power 0 is always 1, except for 0 to the power 0. 0 to the power 0, if you put in your calculator, will give you math error. It cannot, it's a non-real number, so you cannot do that. Over here, everything is raised to the power 0. That is why it is 1. And over here, so just be careful, it's 5 times. So remember, when they're standing next to each other, they're vibing, they're multiplying. So you keep the 5 and the x to the power 0 becomes 1. And 5 times 1 gives you that 5. Okay, and then again, we never, ever, ever leave our answers with a negative exponent. So if we're going to do this over here, we're going to get 2 to the power negative 2. Because there's a 1 over there. The rule that we're applying is law number 3 and 4, where we say everything inside that bracket is raised to the power negative 2. So don't be afraid of that negative 2. Don't be stressed. We're going to just follow our rule. So it's going to be 2 to the power 1 times negative 2 is negative 2. X, negative 2 times a negative 2 gives you a positive 4. Y, 3 times negative 2 is negative 6. So now you can see in our answer, 2 to the power negative 2 and y to the power negative 6, we do not like to leave our answers with negative exponents. So that is where the next slide is going to come in, explaining how to change a negative exponent into a positive exponent. All right, so let's have a look over here. So how the rule to change a negative exponent to a positive exponent is you want to see who's naughty. Naughty is a negative, and we want to change him. We want to change his direction. We want to make him become a positive. So for that to happen, we need to always have our expression written as a fraction. So over here, I talk about upstairs, downstairs, your upstairs and your downstairs. If I had to have the number 2 and I say to you, force it to me into a fraction, you'll just say, okay, I'm going to put it 2 over 1. So that is why x to the power negative 1, we force it into a fraction and we put it over 1. So now, who's naughty? This negative 1 belongs to the x. So to change his ways and become a positive little boy or girl, we're going to change his ways and go put him downstairs. So at the bottom, it's going to be x, and now because he changed his ways, he can now become a positive 1. Now if you've got nothing left on top, you always leave it as a placeholder as 1. So your simplified answer is 1 over x. All right. If you've got 2 to the power negative 2, again, did I have an upstairs, downstairs? Let me do this in a different color. Let's do green. Okay, so we have our upstairs, downstairs. All right, who's naughty? The 2 to the power negative 2 was naughty. They need to change their ways. They need to go and stand downstairs. So if you have your upstairs, downstairs, when the 2 to the power positive 2 goes and sits downstairs, he joins the 1. But 1 times 2 to the power 2, 1 times anything stays that anything. And that's why that 1 sort of seems to be falling away, but you're actually multiplying those two together. So whenever something joins upstairs or joins downstairs, because we're working with one term, they are standing next to each other, which I always say they're vibing, they're multiplying. Okay, so whenever they stand next to each other, they're vibing, they're multiplying. If there's nothing left on top, there's a 1 placeholder, and then you can simplify that 2 to the power 2, which makes it 1 over 4. Okay, let's change this to a nice blue. Again, we're going to create our upstairs, downstairs. Who's naughty? The 3 to the power negative 3. So he's going to go stand downstairs, and if there's nothing left on top, there's a 1, and 1 to the power 3 is 27. So it's 1 over 27. So you cannot throw that 1 away when it's upstairs, but when it's downstairs, let's say you got 27 over 1. then you are more than welcome just to go write that the answer was 27. But when it is 1 over 27, you can't throw away that 1. It forms a fraction, which is very important to see the difference between a fraction and just a number. All right, so over here, creating upstairs, downstairs. Let's do orange. Okay, create my upstairs, downstairs. Now, who's naughty? Who has got a negative exponent? So listen carefully. Who's got a negative exponent? Not who's a negative number. Who's got a negative exponent? And that x has got a negative exponent. Negative 2 is allowed to be, it's an integer, it's allowed to be a negative number, but we don't want a negative exponent. So then we're going to have our upstairs, downstairs, negative 2, you were fine, you were good, you stay upstairs, but then the x to the power 1 goes to the bottom, and simplified, you can just write it neatly, negative 2 over x. Okay, then over here, the whole of the negative 2 is raised to the power negative 2. So we're going to put it over 1. So the whole bracket, because they've put it inside bracket, it means the whole bracket was naughty. And he's going to go downstairs. So when there's nothing left on top, there's a 1 left. And then a negative 2 now raised to the power positive 2. Okay, so the negative 2 exponent became a positive 2. Not the number. There's no way you can make a negative number, positive number by just changing its direction. It's the exponent that's sign changes. Okay, and that would give you 1 over a negative to the power 2 becomes a positive, because a negative to an even number becomes a positive. 2 times 2 is 4, which is a quarter. Okay. Very quick, upstairs, downstairs. He must go upstairs. He's going to go join the 3 upstairs, and he's going to become a positive little boy or girl. And now it's over 1, but because it's over 1, you can actually drop that bottom part and just write 3 times 25, which is 75. 5 squared is 25, 25 times 3. So remember, when they join upstairs, they're going to vibe, they're going to multiply. Okay, let's look at this one. 1 to the power negative 4. If I put it over upstairs, downstairs, the 1 is going to stay on top if there's nothing left, and it's going to be 1 to the power positive 4, which is 1 over 1 times 1 times 1 times 1 gives you 1. 1 over 1 gives you 1 as the answer. And you can always check it on your calculator if you just want to make sure 1 to the power negative 4, if you punch it in, does give you 1. Then a power, let's get into the more nitty-gritty ones. A power raised to a further power, you multiply. So you get 2 to the power of negative 10, because a negative 5 times 2 gives you negative 10. How do I make that a positive? 1 over 2 to the power of 10. So I'm just going to do it a little bit faster. And 2 to the power 10, you can punch it into your calculator, is 1 over 1024. Alrighty, tighty. Let's choose a nice color. Okay, over here. Who's naughty? This one, he's going to go upstairs. Here, a power raised to a further power, we multiply together. So it's going to be 7 to the power 14. You can put it over 1, but because it's at the bottom, you can let it go. Times 7 to the power 2 times negative 7 gives you negative 14. And now, because we're multiplying, we keep the same base and we add the exponent. So 14 plus minus 14 gives you 7 to the power 14 minus, because a plus minus makes a minus. 14 minus 14 falls away, or it becomes 0, and 7 to the power, anything to the power 0 is 1. Okay, with the next one, we're going to create our upstairs, downstairs. All the naughty ones, that one's naughty and that one's naughty, is going to go downstairs. What's left? And the y to the power negative 6 is naughty. So the only thing that is left upstairs is y squared. All the rest must come and stand downstairs and become positive. Okay, then you're going to be left. These ones can divide out so long. 6 minus 2 is 4. Where did my power lie? So immediately we're going to make it a positive, which is y to the power 6 minus 2 is 4. And x times x, you keep your same base, and 4 plus 2, is 6. If there's nothing left on top, remember your placeholder to show that it is a fraction. All right, now we're going to start with some examples that my class had to do for today. And I could see that they were okay, but some of them, I think there were just some that they're just a little bit uncertain every now and then. Okay, so I thought it well just to take a few examples and run through it with you. So when there's a whole fraction to the power negative 2, we can swap this around, the whole what's happening on the inside, and make it to the power positive 2. So then we can have 12 over 11. And by doing that, the swapsies, then that negative 2 becomes a positive 2. And then you can say, well, everything inside the bracket is to the power 2. So 12 to the power 2 is 144. And 11 to the power 2 is 121. Okay, next one. Because this one is a negative, we're going to change his ways. You're going to go to the bottom, you naughty little thing. And if there's nothing left on top, it's a 1. And because they're joining each other, they're standing next to each other, they're vibing, they're multiplying. And 6 to the power positive 2. And then you can work that out. 6 squared is 36. 36 times 2 gives you 72. Just want to double check. Yeah, it's 72. So 1 over 72. Okay. Over here, I'm going to create my upstairs, downstairs, because both of them are naughty. They're both going to the bottom. And if there's nothing left on top there, you put a 1. And it's going to become a positive 2 and 5 to the power positive 1. So then you're left with 4 squared, which is 16. And 16 times 5 gives you 1 over 80. Okay, let me use the red again. Okay, so over here, everything inside the bracket is raised to that power negative 2. My base is the 3, so you're not going to change the base. You keep your base. And a power raised to a further power, you multiply together. So negative 3 times a negative 2 gives you a positive 6 over, keep your base the same, negative 4 times negative 2 gives you a positive 8. And then if you want to pop that in your calculator, you can. 3 to the power 6 is 729. All over 2 to the power 8, which gives you 256. So 729 divided by 256. It stays like that. There's no simplified version of that fraction. Okay. Then, if everything is to the power negative 2, again, you can swap the whole bracket around and make it to the power positive 2. But what you do on the inside is you are not allowed to touch any other exponent on the inside. They must stay exactly the same. You just swap them around. So in actual fact, because the multiplying it out would have given you a positive, it would have been easier to go the other way. But anyway, let's do it both ways. So then you're left with y to the power, a power raised to a further power gives you negative 4, and x to the power negative 2 times 2 gives you negative 4. And then we're just going to swap them around to make them a positive. Okay, so the other way you could have done it is you just said a power raised to a further power. X to the power negative 2 times negative 2 gives you a positive 4 over y. Negative 2 times negative 2 gives you y a positive 4. Can you see that you get the same answers, luckily? Okay. Then, all right. So over here, I would like to make this the negative 3 a positive 3. Okay, so I'm going to swap all of them around. So whatever's standing at the bottom goes to the top exactly as it is. And at the bottom, at the top goes to the bottom. And now it is all raised to the power positive 3. Now everything inside that bracket is raised to the power 3. The 12 to the power 3 gives you 1728. Negative 3 times 3 gives you negative 9. 5 times 3 is 15. All over. 8 to the power 3 gives you 512. To the power negative 2 times 3 is negative 6. 4 times 3 is 12. Okay, I'm just going to see if this can simplify. 1728 divided by 512 gives you 27 over 8. So you write it exactly like that. Then the m's are going to swap around. So it's going to be m to the power 6, m to the power 9. And this one, because they're both positive already, you can just subtract the exponents. 15 minus 12 is 3. Where did my power lie? At the top. So then again, you can simplify those m's. So you'll be left with 27. 9 minus 6 is 3. Where did my power lie? At the bottom, n to the power 3. And there's your answer. Following your basic rules as you know them. Okay, so again, I'm going to swapsies it around and make everything to the power positive 2. How do I do that? Downstairs goes and stands upstairs exactly as it is, and the upstairs goes and stands downstairs. Then I'm going to start. Everything inside the bracket is to the power 2. 3 to the power 2 is 3 times 3, which is 9. Lots of you write 6. I don't know why. A, 3 times 2 is 6. B, negative 8 times 2 is negative 16. Over 2 to the power 2 is 4. A, 2 times 2 is 4. B, negative 6 times 2 is negative 12. These two are negative. They're going to swap around. So I've got 9. I'm somehow going to divide these two out so long. 6 minus 4 is 2. Where did my power lie? At the top. And then I was left with B12 and B16. So the final answer is 9a squared over b to the power 16 minus 12. It's 4. Okay, shoo, we are almost done. We've just got 3 more sums to go. Okay, so again, I'm going to swapsies all of them around and make them to the power positive 3. So 3y to the power negative 2 times 3y to the power negative 2. Oh, wait a minute. We've got an addition here, which is very, very scary. We must be careful because we can't go everything inside the bracket is to the power 3. Why not? Because we've got 2 terms sitting over here. But luckily, they are like terms. So always see whether you can simplify inside the bracket at all. And you can. I'm going to simplify the top there as well. 3 times 3 is 9. Y to the power negative 2 plus minus 2. Remember, you multiply. I always call it the snare. You multiply the signs. So the signs were both positive. Then the numbers. Then you apply the exponent rules. So the signs were both positive, which give you positive. 3 times 3 is 9. And y to the power negative 2 times y to the power negative 2. Remember, you keep your same base and you add the exponents, which will leave you something like that. So it's not y to the power negative 2 minus another 2, which gives you 9y to the power negative 4 over 3y squared plus 3y squared. They're 2 like terms, which gives you 6y squared. Okay, 3 of those plus 3 of those gives you 6 of those. And it's still all to the power 3. Now we're going to go, everything inside that bracket is to the power 3. The 9 to the power 3, which is 729. Y to the power negative 4 times 3 is 12 over 6 to the power 3, which gives you 216. Y to the power 2 times 3 is 6 Okay, now we're going to check if the numbers can divide out a bit. So you just say 729 divided by 216. Yes, it can. 27 over 8. And then this one is going to go downstairs, and then they're going to go vibe there, and they multiply, and they're going to become a positive. So I'm just going to do it like that. 6 plus 12 is 18, so it's y to the power of 18. Two more to go. Okay, again, everything is to the power 5, negative 5 at the top, only the top. So can you see the brackets only belong to the top part over there? So I'm just going to go ahead and say a power raised to a further power, you multiply. So I'm going to go there. A to the power negative 2 times negative 5 gives you a positive 10. B, negative 1 times negative 5 gives you a positive 5. C, if there's nothing, there's a 1. And 1 times negative 5 gives you negative 5. Over A to the power 7, B to the power negative 2, C to the power 4. Now we need to decide who is naughty. Who is naughty? You are naughty. And those are going to switch their ways. So then I've got A to the power 10. B to the power 5. He's going to go downstairs. She's going to go upstairs. So B to the power 2 is going upstairs. Then I've got A to the power 7 left. C to the power 4. And this C also came down. And he became a positive. And then we're just going to clean up. The A10, A7 can divide out. 10 minus 7 is 3. Where did my power lie? At the top. B to the power 5 and B to the power 2. Keep your same base and add your exponents. At the bottom, C to the power 4 plus 5 is 9. And there's your answer. So if you want to write it nicely again, so you can see A to the power 3, B to the power 7 over C to the power 9. Last example. Again, we're not going to do a switch around. It's everything inside this bracket is to the power negative 2. So we're going to start 4 to the power negative 2. A, 3 times negative 2 is negative 6. B, negative 2 times negative 2 is a positive 4. Over 4, A to the power 6, B to the power negative 4. Who is naughty? Who is naughty? Those are going to go to the bottom. This one's going to go to the top. And you can highlight, you can encircle the ones that are naughty like this. So what is left at the top? There's a B to the power 4. And now this one's going to go to the top. So another B to the power 4. Over. This one was there downstairs first. So he stays. Times 4 to the power 2. Times A to the power 6. So these two I just brought to the bottom and they joined there. Okay, so then I've got B to the power 4 plus 4 is 8 over. Now the snare, remember your snare. Snare, first the signs are all positive, so it's going to be a positive. Then the numbers, 4 times 4 is 16. 8 to the power 6 times A to the power 6 gives you A to the power 12. Phew! And that is it. There I've explained all the ones that are quite hard exponents. But as you can see, if you just follow your basic rules, it really it isn't that hard. Okay, so just keep to your rules, and that's why the easier ones are so important to do, so that when the harder ones come, you are more confident to do it. Okay, all the best grade 9s. I hope you really do understand exponents. It is very important going forward, and I hope you all have a wonderful, wonderful day. Thanks for watching. Bye.